So, ladies and gentlemen, once again, you're all cordially welcome to the Valley of the Shadows of Research Methods. You've looked at the steps in hypothesis testing, and these are the various steps in hypothesis testing. Actually, they are very smaller, okay, as you will see. But in order to hypothesize, you got to know what to do to hypothesize. So we're going to hypothesize. But the key point is to learn some important words, okay? I'm going to show you some important words. So please look on the screen and let's do some very quick analysis of hypothesizing. Number one, there is something we call the null hypothesis. The null hypothesis is the population statement, okay, that you can make. And is usually made by someone with an authority. Someone with an authority. For example, if you make the statement that NDC won the election, and then electoral commissioner also says that NDC won the election, which one is going to shake the country? I need a hand raise. Which one will shake the economy, will shake the country? You saying it, or the electoral commission saying it? Which one is going to shake our country? Marcus?
The one made by the EC.
Okay, I don't want to even ask you why, because we all know why. Okay, that is a null hypothesis. It's populative authoritative. Okay, if you want to challenge that, you will make an alternative hypothesis. You will make an alternative hypothesis, which is a mirror image, okay, of the null. Okay, it's a mirror image, it's alternative to that. It's not opposite. It's very important. It's not just opposite, it's alternative to that. And we are going to learn how to formulate the null and alternative hypothesis right now. Now we formulate the hypothesis around the mean, represented by mu, the Greek letter mu. So many things have means. The salaries have means. Your average salary in a year has a mean. The average ages in this class has a mean. The average height has a mean, has a median, has a mode. The average weight has a mean, has a median, has a mode. The average food that people normally eat. So we can use the mean to represent a lot of things. So we talk around means. And we talk around the mean, or we talk about the mean, or we use the mean to represent the population. So we speak of the population mean. So I'm going to give you a couple of statements, and then you help me in formulate. I'm going to take a typical example of statement that can help you learn how to formulate step one. Who can remember step one? Step one says formulate the null and the alternative hypothesis. Formulate it. And how do you do that? Okay, so let's take a typical example. But before we do that, let's get some keywords. There is a difference between mathematics and English. In English, the way people speak English is a little bit different from mathematics. For example, what is the opposite of stronger? Who can tell me? What is the opposite of stronger? What is the opposite of stronger? Stronger. Araba?
Weaker.
Good. I know that's what I'm going to say. But that is not really the truth in statistical science. Let me give you another example. What is the opposite of greater than? Greater than. You can tell us. What's the opposite of greater than? Just say what. Lower your hands. Lower your hands. You raise your hand and talk. Okay. Yes, Marcus.
Less than.
Less than. That is wrong. Statistically speaking, that is wrong. And that's what you're going to learn here. That the opposite of greater than is not less than, but is rather less or equal to. Opposite of greater than, which is this, is not less than, but is rather less or equal to. Let me give you a typical example of something that we already know. Let's say that I tell you that she has they have an average weight, okay, of 30. The average age in this class is 30 years. Is a symbol which means equal to. So the opposite will be is not equal to 30. That one we all know. But if I say that the average age in this class is less than 30, you cannot tell me that the opposite of that or the alternative of that is that the average height is greater than 30. This is wrong. This second one is wrong. Why? Why is this wrong? It's wrong because one of them can be 30. If you tell me that the average age is less than 30, the opposite is that the average age, I know is greater than 30, but what about the person who is equal to 30? So the opposite is this. I think it's clear. It makes sense. Because other than that, you will not know where to fix somebody who is 30. Because then we have below 30, and then we have above 30, and so 30 becomes useless. So for 30 to be part of the number line, the opposite of less than is greater than or equal to. What is the opposite of greater or equal to? Who can tell me? What is the opposite of greater or equal to? What is the opposite of greater or equal
to? Less than.
Oh, please, can you raise your hand for me? Because imagine if 10 people, all of them want to say less than. Okay. Oti?
Less than.
Okay, so the opposite of greater or equal to is less than. Okay, that's the opposite. Less than. And why do we say so? Because you understand now. Now, let's go back to our storyline. There are English words that can depict these symbols. These symbols are very powerful symbols. And they are the symbols that we use in any particular, statement. But these symbols are very, very powerful, and you need to know what they really mean. What are the symbols? Well, the symbols are less than, whose opposite is greater or equal to, greater than, whose opposite is less or equal to, okay, and then not equal to, which opposite is equal to. Now, these symbols that you are seeing here, the first four here, they are called one-tail testing. They are used for one-tail testing. And then these last two are used for two-tail testing. Now, two-tail because the direction is two-directional. For example, if I say she is not 30, it means that the opposite is that she can be above 30 or below 30. You see, above is one direction, below is another direction. So the two becomes two-tail. But if I say that she is not, she's not, even if I say she's less than 30, she's less than 30. The opposite is going to be greater or equal to 30, and the direction is going to be only one direction. Okay, 30 or more. 30 or more. So these symbols, you got to know the names that we have for them. Now let's go to English and match English words in connection with these symbols. Okay. So I'm going to now ask you to tell me the symbol for these words in English. The first one is greater than. And as for that, the answer is very simple because the symbol for greater than is simply greater than. There's no question about that. The symbol for greater than is simply what? Greater than. No question about that. Now, what do you think will be the symbol for below? Who can raise a hand and tell me? What is a symbol for below? Below. Below. What is a symbol for below? Amanda.
So please, I'm not answering the question. I want you to go over the details in one table.
I can't hear you.
I'm asking you to please go over the details in one table for me.
Which specific one? You have to be cleared, and your voice is far away. I can't also hear you.
My network is not very good.
So if the network is not good, then maybe what you want to do is to get a recording to understand. Because then the problem is not from you, and it's not from me. Does that make sense? Because the problem is not from you, it's not from me. So you wait to get a recording and you take your time and then you master it.
That's fine. Thank you.
Okay, all right. So now let's move on. Let's move on. What is a symbol for below? What is a symbol for below? Okay, based on our understanding of the symbols. Okay, so those are the symbols you see on the top of your screen. What is a symbol for below? Below. Benjamin Nyakpo. Benjamin, what is a symbol for below? Benjamin. Okay, Araba.
Doc, I think it will be that of lesser than.
Less than. Good. What is a symbol for beyond? Anybody? Symbol for beyond. Emma.
Greater than.
What is a symbol for fewer than? Fewer than. Not what is here, but I'm just using something else. What is a symbol for fewer than? Not fewer than, but fewer than. Fewer than. What is a symbol for that? Fewer than. Tariq.
Less than.
Good. So what do you think will be the opposite of that, which is not fewer than? What will be the symbol for not fewer than? Emma?
Greater than.
No. What is the
Greater or equals to.
greater or equal to? That's the answer. What is the symbol for not above? Not above. What is the symbol for not above? Not above. Emma?
Less than or equals to.
Less than or equal to. That's correct, because above is greater than. What is a symbol for better than? Better than. Better than. What is a symbol for better than? What symbol is better than? Look at now. Tell me the symbol for better than. Okay. Araba.
Greater than.
What symbol is worse than? Worse than. Araba. Araba.
Lesser than.
Okay, we say less than. That's the word.
Less than.
Lesser. Okay.
Yeah.
What symbol is at least? Sandra Sosu. What symbol is at least? At least. At least. Augustine Koku. Oh, sorry. Benjamin, what symbol is at least?
Equal to.
At least is greater or equal to?
Greater or equal to, yeah.
Or equal to. Okay, that's at least. Greater or equal to. What symbol is not at least? Okay, let's go to at most first. What symbol is at most? Araba.
Greater than.
At most is not greater than. What symbol is greater than? What symbol is at most? Doris. At most.
Dog, Augustine here.
I said Doris. Augustine, don't raise your hand there. Emma, what symbol is at most?
Less than or equals to.
Please, I'm asking, I say greater than or equal to.
All right, okay. So at most is less or equal to. Okay, that is at most. At most is less or equal to. So that is at most, less or equal to. Okay, not at least. You always have to remove the not and deal with at least. Okay, not at least here, you have to remove the not and then first deal with the at least. So at least is greater or equal to. So the not will make it opposite. And opposite of this becomes less than. Okay. Not younger than. Don't deal with the not. Deal with the younger than first. Okay. What is younger than? The younger than is less than. So what is the opposite of that? Opposite is greater or equal to. So that is the not younger than. That's actually the not younger than. Then above. Above is greater. Above is greater than. Okay. So those are the symbols that you have to appreciate and understand. Okay. All right. So these are the symbols you have to appreciate and understand. Yes, Emma.
Please, I wanted to just find out.
Sorry, Emma, unmute yourself again.
Okay. Sorry. Please, concerning the not at least, okay. You said it's the opposite. So since it was greater than or equals to, if it's the opposite, it won't it be less than or equals to, or it will just be
No,
less than?
it will be less than. Like I've indicated, opposite of. You see, don't look at it in terms of English. If I tell you that this girl is greater or equal to 30 years, the possible numbers will be 30 going. Isn't it? Greater or equal to 30 years, the possible numbers will be 30 and above. So what is the opposite of that? It will not be 30 and below because you've already counted 30. So it will be just below 30, 29, 28, 27. And
Yes.
that. Okay.
Yes. Thank you.
So that is it. Let's go to the two-tail inspirations. Okay. The two-tail inspirations mean that we are dealing with where it will indicate equal to or not equal to. Now, as the first one sounds, as you can see, it is clearly not equal to. The word not equal to in English simply means not equal to in symbols, which is this, not equal to in symbols. What word, what symbol will be not different from? Who can tell me? What symbol will be not different from? What symbol will be not different from? Amanda.
Equal to.
It will be equal to. Okay. What symbol will be different or differs from? Differs from. What symbol is that? Tariq.
Not equal to.
Okay. What symbol is the same as? The same as. Jerry.
Equal to.
Equal to. Does not vary from. Does not vary from. Stephen.
Equal to.
Equal to. On. What symbol is on? On. Jerry.
Equal to.
Equal to. What symbol is off? Off. Off. Shadrach.
Not equal to.
Not equal to is wrong. It's equal to. What symbol is was? Was. Stephen.
Equal to.
Equal to. Okay. So the last four are all equal to. Just put it down. One day you need it. Okay. One day you need it. Okay. Now let's try to hypothesize. I'm going to take a simple example of a statement, hypothesize for you, and then after that we'll go and do the rest. So look at this statement on your screen. This statement says Nescafe Ghana claims that since the mean population mean filling weight is at least 3 pounds per can, since the population mean filling weight is at least 3 pounds per can, consumers' rights are protected. Whenever you get a statement or even a story or a whole paragraph, the key point is to look for those symbolic words that we started with. But before you hypothesize, this is what you should do. Okay? This is what you should do before you hypothesize. Okay? Write your null hypothesis. Okay, just a second. Write your null hypothesis. And then bring a colon. No, that's not how you do it. Because you have to do it in a beautiful way than this. Okay, so let me show you. The first thing you want to do is this. You write mu. Oh, okay, this thing is too thick, so let me change it a bit. You write mu okay, and then leave a space, and then write the number that has been given to you. And actually, you have to write the second mu and also leave a space. And then look out for the number that is indicative in the sentence. And in this case, the number is 3 pounds. The pounds is just indicating the unit of measurement. So you leave a space and write 3 pounds. 3 pounds. Now, there must be a symbol in between the mu and then that. The second bottom one is the opposite of the first one. The second one is simply not really the opposite, the alternative of the first one. So what is the key word in this sentence that is symbolic? Because we've looked at a lot of mathematical symbols. Okay. If we're
At least.
Thank you. What is the symbol for at least if we're?
It's greater than or equals to.
So that is what you put down here. So every time you will first write your mu and look for the number, put it on the right side of it. You write the next mu, put it on number, put it on the right side. Now look for the key symbolic word. That is at least. You put that at least down. Then you step back, you step back, you step back. And then relax and know that this is not Hebrew. Then you ask yourself, what is the opposite of that symbol? That's what you do. You ask yourself, what is the opposite of that symbol? And then you put the opposite down. So what is the opposite of greater or equal to? Who can tell me? Shelley.
Less than.
So you put that less than down in the second one below. You put that one down in the second one below. Okay. Now that you are done with this, you are left with 2 more. Bring colons in front of each one of the mu's. Bring colon. Colon. Okay. Colon. My colon is not showing well. That's why I'm trying to do it many times. But you have to do it only once. Colons. Without the colons, you lose everything. And this is where it becomes critical. Then you ask yourself, the top one and the down one, which one is the null hypothesis? And always note this down. Put this down somewhere in your note, that the null hypothesis always carries some level of equality in it. The null hypothesis always carries some level of equality in it. The null hypothesis has some level of equality in it. So looking at these two, is it the top one or the down one, which is the null hypothesis? With this storyline, is it the top or the down one, which is the null hypothesis? Better.
Is the top one.
Is the top one. Now that you know is the top one, write H. Okay. Now that you know is the top one, you now indicate that as HO. And automatically the down one becomes HA. You have been able to formulate the null and the alternative hypothesis. Now, I know how students are. I know how sometimes students struggle to, understand things. I just want to go over it slightly quickly again for you to appreciate what we are doing right here, because you need to master this. So you don't write the null and alternative hypothesis first, okay? First thing you do is that once you look at a storyline, you write the mu and another mu, okay? You write the first mu and then another mu. That's what you do. First mu and then second mu. Then you look out for the number that has been indicated in the sentence, and the number is 3 pounds per can. 3 pounds per can. 3 pounds per can. Okay. Then you ask yourself, what is the symbolic word in the sentence? And if you look at the sentence carefully, the symbolic word is at least. That's at least. And you ask yourself, what's the symbol for that? That symbol is greater or equal to. You write it down. That's the first thing you do. Then you ask yourself, what is the opposite of the symbol I just wrote down? And the opposite is less than. Then you bring a colon in front of the mu. You bring a colon in front of the mu's. Then you ask yourself, which of these two, the top and the down, which of them two carries some level of equality? Well, if you look at this one, the first one, it carries some level of equality. That is a null. That is a null. and then you write HO in front, automatically it makes this one HA. You've done your null and your alternative hypothesis. That's it. Any question on this? Because you're going to do another one by yourself. Any question? Any question? Any question? Any question? So I want you to do this one that is down here. Max Flight uses a high technology manufacturing process to produce golf balls with a mean driving distance of 295 yards. Now, what I want you to do is that if you think you can do this and you can write a null and alternative hypothesis for this, just raise your hand and you will walk me through it. Raise your hand. I see 2 hands. Is that all? Okay, let's go, Amanda.
Okay, so it says Max Flight uses a high technology.
So you're going to say it and I'm going to write it.
Okay, so it says they use a high technology manufacturing process to produce golf balls with a mean driving distance of 5 yards. So first we'll write the mean sign.
I should write the mean.
Yes. And then we are going to take.
I have not written the mu sign and you say and then.
Okay, sorry.
Have I written correctly?
No.
Okay. That is why you have to walk me through it. What else?
Then we'll take notice of the word of, which in other terms is equal to. So we'll write the equal.
Just tell me what I should write. Don't tell me what
equal. Okay. So equal to.
I should bring equal to.
Yes. No. Okay, no, wait. So we'll leave the space and write 295.
Okay. 295 yards.
Yes. And then we'll do the same for the bottom.
Do you realize that teaching is not that simple? Now that you are teaching me, you see the way you are going around. What else?
Okay, and then we'll put the colon by the mean sign.
I should put what?
The colon.
Where?
By the in front of the sign.
I should put the column. I've done that.
Okay. So now we would write equal to the top one.
The first one. Okay.
Yeah, the first one. We'll put an equal to sign. And then the second one, we'll put a not equal to sign. Then the first one, because it has the equal to sign, that is the null hypothesis. So we'll write the
All right, that's well done. That is excellently done. That is how you formulate the null and the alternative hypothesis for this. Very good. Let's take one more. Okay. Let's take one more and then see how it goes. Marcus, is your hand up?
Yes, sir.
For the one more we're about to take.
Yeah, what the equal sign and not equal sign, how did she come by? What word that gave us the equal to and not the equal to?
All right, she will answer you.
Thank you.
Okay, so Marcus, when we were looking at the previous slide, we're going through what the words mean in the symbol form and came across of which, when he asked, we agreed that it meant equal to.
Marcus, the equal to sign comes with the word of 295 yards off.
Thank you very much.
Okay, when we were going through the examples, it was one of the prepositions that we use to indicate equal to sign. Let's take another one. be careful with this one because this one is a little bit tricky. According to the CEO, the new BMW car can run more than 294 miles per gallon. Who can write the null and the alternative hypothesis? The null and the alternative hypothesis. Who is bold? Stephen, walk us through it. We are ready. Stephen, you sound far away.
Please, is it better now?
Go ahead.
Okay, so from the statement, the car can run more than 24 miles per gallon. So I'll first begin with the number. So for the top, I'll write 24 miles per gallon, both up and then down.
So I should write 25 mpg and then 24 mpg. That's according to you, yeah?
Yes, please.
Okay.
Then for the so we would have a mu for both the top and then the down.
Where should I have the mu?
I wanted to use a symbol, but then I don't know if I should use so the mu is
Where should I write the mu?
So both up and down, please.
I should write the mu both up and down like this.
Yes, please, both up and down.
Okay. I've written the mu both up and down.
No, before the 24.
So do you remember I asked you where should I write it?
Yes, please. Sorry, it should be before the 24 mpg.
Mass is a pattern, so you want to follow the pattern.
Sure, sir.
So if you tell me that I should just write it up and down, I can even go and write it in front of the CEO.
That's true.
Okay, so I've written it up and down.
Okay. So so from the statement it says more than 24. More than 24, then it means that for the one up would use greater than.
So where should I write it? Behind it?
Between the first mu and then the 24 mpg.
See, now you are being specific. Let's move on.
Yes. And then between the second mu and then the second 24 mpg, the opposite of the greater than will be less than or equal to.
Okay.
Then we bring a colon before the mu in both instances, so both up and down. So H naught or H O would be the one on the top before the first line to the left.
So this one like that?
Yes, please. And then alternate H A will be down here. Yes, please.
Okay. So that's wrong.
Okay, thank you.
The reason why that's wrong is that I wanted to walk with you so that you can appreciate why that's wrong. Can somebody tell us why it's wrong and what will be the correct one? Who has detected why it is wrong? Who has detected why it is wrong? Benjamin Nyako.
Yes, sir. The mu is greater than 24 mpg is HA, the alternative hypothesis.
Okay, so this is not.
And then
it's rather HA. Is that what you're saying?
HA. Yes, please.
And then?
And the mu is less than or equal to 24 mpg is HO.
So this is
because it has
HO, but it's rather HO. Okay. Now, before we move on, can you just tell them why you indicated the bottom one to be so?
Sir, it is because for every null hypothesis, it always carries some level of equality in it.
Excellent. Very good. Okay. So the reason why you were wrong, my good friend, initially was because you forgot to look at that symbol. Your mind has always been that the first one must always be the null, which is not correct. It shouldn't be so. that the first one must automatically be in a null. In fact, your mind was not even on the symbol. Your mind was not on these symbols. Okay, your mind wasn't on this. And these things should have guided you before you decide on the null and alternative hypothesis. Okay, so that's how it's supposed to be. Okay, so the bottom one, which carries some level of equality, is a null. If you understand that very clearly, then this becomes your final answer as far as the discussion is concerned. The null is the bottom one. Okay, so with this principle, we are going to take a full-blown, storyline and try to crack the code associated with it. I'm going to go to a very long journey. In fact, you can look at the other examples later, okay? But I'm going to take you now through a very long journey, which will now help us to get the entire picture. Now we are going to go into a bigger move. And you want to pay attention here because we are putting everything together and more that we have not even discussed. This is a storyline. It's one of the projects I did. It's a storyline. And in this storyline, we want to be able to make a statement or a conclusion to a statement. We want to hypothesize and finally conclude the hypothesis. So this is a full-blown kind of hypothesis question that you want to consider. I will need someone to do the reading for us. After that, we will fish out the key elements in this question. Who will do the reading? Araba.
Right. Suppose that you are thinking of taking over an SME. The current owner claims the weekly turnover of each existing SME is not different from 5,000 cedis. And at this level, you are willing to take on the SME. You would be more cautious if the turnover is below this figure. You examine the books of 26 SMEs chosen at random and find that the average turnover was 49 cedis, with standard deviation of 280 cedis. What would you do?
Thank you. What would you do? What would you do? Now, the first thing you want to do, and this is a full-blown, so it goes just beyond the steps in hypothesis testing. The first thing you want to do is to identify some 5 key elements. 5 key elements, always when you're looking at situations like this, 5 key elements. And the first one of the 5 key elements is to identify the population mean and the sample means. The population mean is, and be doing this in your book whilst I'm doing this, okay? So the first thing you want to do is to identify the population mean. Okay, so the population mean, the population mean is the first thing you want to identify. It's represented by mu. And then the next thing you want to identify is a sample mean. Sample mean. Like that. I want us to talk about this first before we move on. What is the difference between the population mean and the sample mean? Now, the population mean, as the name sounds, speaks about a representation of the entire population. It is a mean that is captured by the population. But how do you distinguish it from the sample mean? Well, here is a very simple point. The sample mean, and you want to know this, please. The sample mean has some level, has a standard deviation following it. But the population mean does not have a standard deviation following it. So the population mean is a number, just like the sample mean, but the sample mean has some level of some standard deviation following it, or standard deviation that come with it. But the population mean does not have any standard deviation that come with it. So, ladies and gentlemen, on the basis of this and looking at the preamble in front of you, what number is a population mean and what number is a sample mean? What number? And by the way, they are mostly closer to each other. These two numbers are usually closer to each other. One number is the population mean, and one number is the sample mean. Who will try that for us? One number is the population mean, and one number is the sample mean. Yes. Let's go to. Let's go to Marcus. Marcus.
The sample mean is 4,900. And the population mean is 26 SMEs.
Okay. You tried, but that is not the correct thing. Let's go to another person.
Thank you.
What is the sample mean and what is the population mean? First of all, remember I told you that these two numbers are closer to each other. Okay. So who can try again? Let's take it to Emma.
The population mean is 5,000. And the sample mean is 4,900.
Okay, why did you say that?
Because he said the sample mean always has a deviation, and from the question, I could see that the 4,900 has a standard deviation of 280.
Excellent.
And
we're listening.
Yes.
And that is very, very good. Because as long as you are listening, you will crack the code. And that is exactly. So the population mean, truly speaking, is 5,000. There's no question, debate about it. It's 5,000 exactly. And the sample mean is 4,900. Because the sample mean has, the sample mean has a standard deviation following it. Okay. The next thing to identify is the standard deviation. And then identify the sample size. And then there'll be something we'll talk about called alpha. So, based on this storyline, you can tell me what the standard deviation is. It's easy. What is the standard deviation? If you haven't spoken today, it's yours. Okay. The standard deviation is what? Tariq?
280.
280, thank you. And what is the sample size? You can tell us the sample size. So the standard deviation is 280. Let me write that first. Okay, 280. And what is the sample size? You can tell us. Yes, sample size, Shadrach.
26.
26. Now, one thing that will help you to know that the sample size is the sample size is that you will notice that it is something that is always randomly collected or selected or taken or chosen. It's collected, selected, chosen, or something like that. That is always the sample size. And it's represented by n. It's represented by n. Now we are left with our last terminology. Okay. Our last thing, and that last thing is alpha. Alpha. What is alpha? Alpha is a level of significance. Alpha is the level of significance. Now I'm going to explain it better for you to appreciate what we are discussing here. Okay. Alpha is the level of significance. So let me create a new page for this. So first, your population.
Oh, please, can you come again?
Yeah, I'll come back.
You don't have
Okay. This is 5,000. The sample mean is 4,009. Okay. The standard deviation is 280. The sample size is 26. And the alpha is the level of significance. Now let me tell you a brief history about the alpha. If you are doing any research, okay, you are allowed to make some mistakes. You are allowed to make some mistakes. The mistakes you are allowed to make, you are expected to make. The mistakes that you are allowed to make, you are expected to make, that is what is known as the alpha. So the alpha is the expected error, the expected margin of error that you are allowed to make. But you got to know that the fact that you are allowed to make that mistake does not mean you should make that mistake. And that is why we have another thing called the p-value. So alpha is a level of significance. The level of significance. And the p-value is the actual mistake. Okay, the p-value is the actual mistake. So the alpha is the expected mistake. Alpha is the expected mistake. Okay, so that alpha is the expected mistake, whereas the p-value is the actual mistake. We'll come back to the p-value and the alpha. Okay, but for now, you should always look into the story to identify the alpha. There are only 3 alphas that we normally deal with in research. Only 3 of them. Because it's a percentage mistake that you're allowed to make. There is 1%, 5%, and 10%. So 5% level of mistake, 5% level of alpha, 10% level of alpha, and 1% level of alpha. The default is 5%. The default is 5%. And please note that, ladies and gentlemen, as long as you are not given the alpha, the default alpha is always 5%. Please note, the default alpha is 5%. So when you look at your storyline, your preamble, and you realize that you have not been given the alpha, then assume that the alpha default one is 5%. Therefore, on the basis of that, we can say without a shadow of a doubt that in this very question, what is the value of our alpha? What is the value of our alpha? Marcus?
5%.
5%. So when you are writing these things, you realize that there is no alpha given. You just write 5%. 0.05. I'll come back to the p-value, but please for now, just note that alpha is expected error and p-value is the actual error. Now, which one would you wish that is smaller? The alpha or the p-value? Alpha is expected error. The p-value is the actual error you make. Which one would you wish is smaller? The alpha or the p-value? Stephen?
The p-value.
The p-value. And the reason is because it's the actual mistake. So you would want the mistake you actually make to be smaller than the mistake you were expected to make. That way you can have enough confidence, and that's why we speak of confidence interval. You can have enough gravitas, confidence to reject the null hypothesis, which is usually the goal. So these 5 things, okay, forget about the p-value because that wasn't really part. These 5 things, you should always identify them in the storyline. The population mean, the sample mean, the standard deviation, the sample size, and then alpha, the level of significance. That is what you identify first. It is after this that you now go and formulate your null and the alternative hypothesis. So please, I want you to look into this storyline and then tell me, formulate the null and the alternative hypothesis using the population mean. Remember, it is always the population mean that we use to formulate a hypothesis. So using the population mean, who can formulate the null and the alternative hypothesis? Of course, using the skills that we have learned. Using all of the skills that we have learned in formulating hypothesis. Who can formulate the null and the alternative hypothesis? Araba.
As usual, we start by writing our now, our 2 now.
Our 2 now.
Then,
don't start writing our 2 now.
Sorry?
So we start by writing our 2 now, and I say we don't start by writing our 2 now.
is the first one and then the second one.
So what should I write first?
The first now,
What would I put down first in pen and paper? What would I put down? I want you to say it not as if you are directing me, but you are writing it yourself. What would you write down first?
now.
Now. Oh, then you are wrong.
Yes.
So don't start by that.
Oh, really?
Yes. If that's how you start it, then that's not correct. Let's go to Shadrach. Yeah, Shadrach.
So we should start by introducing our mu.
Good. That's the first thing you want to put down. Okay, a pattern. I showed you a pattern about how to go about it. So the first thing you do is to put down the mu. Okay, so let me write the mu. And what else?
And then a little space to your right. Let's introduce our 5,000.
Good. A little space, you write your 5,000, which is the population mean.
And then below it, we introduce our second mu.
Yes.
And then introduce our 5,000 again.
Yes.
We introduce our colons in front of the first mu.
Okay, that shouldn't come first. That shouldn't come next.
Okay, then, okay. Let's look out for the not different, which symbolizes equal to.
Okay, what word is guiding you to know that?
Not different.
Yeah, what word? The word, the phrase is what? Not difference in the storyline.
It's not different.
Good. So
Yes.
for your information, he's able to get the null hypothesis from this keyword different. Let's forget about the not. Different. Like I always say, forget about the not, deal with the word after the not. And that is different. So you are asking yourself what symbol is different, and you got to know to be what? What symbol is different?
Not equal to.
Not equal to. So that is not equal to. Okay. Its opposite is what?
Equal to.
Okay, now you can go ahead with your colons. Continue.
If we've interchanged it.
Of course it should be interchanged. It doesn't matter what has been interchanged. I told you that there is no guarantee.
Okay, so HO will be put on the one underneath.
Good. So HO is just a down one.
And then HA will be the one up above.
So let me tell you something. Why, you thought it was wrong because it has been interchanged?
Yes, just for a moment.
Oh, how can that be? If y is equal to 4 and 4 is equal to y, does that make it wrong?
Exactly.
So there's no problem with interchanging. And we did an example that also showed that it has been interchanged. So I don't want you to have a very one-sided mind that the null must always come first, because once you have that mindset, you will not consider the bigger picture. All right, but that's very good. You've been able to formulate a null alternative hypothesis, but you need to understand what that means in English. Because it's not a matter of just writing it statistically down, but understanding what it means in English. So what does the first one, or the down one first, what does that one mean? What it means is that the mean turnover is 5,000. That is what it means. Okay? That's what it means. The mean turnover, okay? The mean weekly turnover is 5,000. And then this one is saying that the mean weekly turnover, okay, is not 5,000. You got to understand what this means. But then you have to understand what they also mean in practical sense. Let's go back to the storyline and you understand what I mean by this practical sense. See, it says that you are not going to, you will be more cautious if the turnover is below that figure of 5,000. Okay. And that you have been told that by the current owner. Okay. The current owner claims that the weekly turnover is not different from 5,000, which means that the weekly turnover is 5,000. So if the weekly turnover is 5,000 and you go and check the books and it's actually 5,000, will you buy the company? Will you buy the SME? Well, according to the sentence, it says that at this level, you are willing to buy the SME. So that statement where the weekly turnover is 5,000, its implication is that you will buy the SME. So you got to understand this sentence. So in order to understand what is happening, okay, you can now attach that sentence here, okay, that mu equals to 5,000 also means that you buy the SME. That's what it means. You buy the SME. And then the one above will mean that you will not buy the SME. You will not buy the SME. So that is the first step, which I just want you to understand in practical sense. Because this is not just mathematics. You have to understand the practicality of it. Okay. So now that we've done that, let's go to the step 2. Step 2 is calculating your test statistic and the critical value. Your test statistic and the critical value. What is a test statistic? There's a formula for calculating the test statistic, and it's given by T. Okay, let me just write that. Okay. The test statistic is given by a formula. And the formula for the test statistic is T, and that, of course, is a T statistic. Okay. This is T statistic. So you start with T equal to X bar minus mu over the standard deviation. And again, it depends on how you're looking at it. We are looking at sample. So we deal with sample standard deviation over the square root of n. This is a formula that you are given that is going to calculate the test statistic for you. Of course, if it was a software, the software will calculate this straight away for you. So what is this formula? Well, this formula comes from all the terminologies that you wrote on the left here. Okay. So what is X bar? What is the value of X bar? Who can tell us? What is the value of the X bar? It's 4,009. And the value of mu, that is 5,000. So we are simply talking about, okay, we are simply talking about getting 4,900 minus 5,000 divided by standard deviation of 280 over the square root of 26. Remember, the n is 26. In fact, this n is supposed to be sample mean, not capital. The capital might look like the population mean. Okay, so the n here is supposed to be the sample mean. Sample. So you just put in your calculator, solve this, and you got to be careful when you're solving this, because sometimes the way some people press their calculators can get them wrong. Okay, you have to solve the top one first, and the top one is 4,000 minus 5,000, which is negative 100. Okay, divided by 280. 280 alone is over the square root of 29. So you need to find the square root, find the 280 divided by the square root of 29 first. Don't divide 100 by the 280. Don't divide negative 100 by the 280. Divide 280 by the square root of 26 first. Okay. Once you have that answer, then negative 100 divided by that. And if you should follow a right step in doing that, you will land, this is where your calculator comes to your aid, you will land at negative 1.82. This is your test statistic. The test statistic is a T distribution. It follows the same Z distribution. And the distribution is usually something like that. The same normally distributed. Okay. And so it is both left and right side. But we'll be dealing with the absolute value. So T is actually absolute value of 1.82. This is your test statistic. Now, what is this? What does it mean? Well, you want to prove something. You want to prove the null hypothesis right or wrong or anything. And so what you have just done is gathering your information. So the T statistic deals with the information gathering. And you got to now juxtapose that against a benchmark. And that benchmark is a critical value. Okay, so the T statistic is the calculated value. And then you match that against the critical value. Sometimes some people use the rejection region, acceptance region, and all of that. It can confuse sometimes. So I'll just jump away from that and then make it a bit simpler for you. So this is your calculated value. Okay, this is the calculated value, calculated T. And we need to compare that with the, okay, with the tabulated. And that tabulated is a critical value. The critical value tabulated means it's on the table. So to be able to get a critical value, you need to learn some small formula. The small formula is given by this. It's given by a certain beautiful formula. T subscript alpha n minus 1. That is a critical value. That's a tabulated. You got to know what alpha is. You can remember what alpha is. What is alpha? What is alpha? What is alpha? What is alpha? What is the value of alpha?
0.5.
Araba. Okay. So alpha is
0.5.
Oh.
0.05.
Oh.
Alpha is 0. Oh. Alpha is 0.5. 0.05. And our n is what? 26. So you have 26 minus 1. Therefore, our T critical is going to be T 0.05 and then 25. Now, this is something you need to identify on the table. That's why it's called tabulated. That's why it's called tabulated. So how do you get that on the table? Well, this 26 minus 1, okay, is the degrees of freedom. So this 2, that is what is known as the degrees of freedom. And so you need to understand that this is the degrees of freedom. So when you go to the table, you need to identify the 0.05 and the degrees of freedom. However, never forget the tail. Okay, what tail? Always ask yourself that question before you go to the table. Ask yourself the question, what tail are you dealing with? What tail test are you dealing with? So who can tell me what tail test we are dealing with here? If you remember the null hypothesis or the alternative hypothesis, what's the tail? Jerry.
We are dealing with a two-tail.
Two-tail, okay.
Two-tail test.
That's what we are dealing with. The two-tail. So the tail is two-tail. Two-tail. So when you go to the table, look for the two-tail, because in the table, you have a one-tail testing and you have a two-tail testing. So let's go to the table. Okay. Let's go to the table and then check what is really happening. So this is the table. I just want to show you the table a bit here. Of course, you have been given the table so you can check everything by yourself. So this is the table, and at the top of the table, you see one tail, one tail, one tail. So everything on the top is one tail, and the very bottom one here, those are the two tail, two tail, two tail. So we are looking for the two tail section and not the one tail. And you are looking for the alpha value of 0.05. So you can see that the two tail that we are dealing with and looking for is this 0.05. Okay, you got that. The next thing is to match that against the degrees of freedom on the far left column. The degrees of freedom on the far left column, we are looking for one number, 25. So you look out for 25 degrees of freedom. That is this. You are going to match that 25 degrees of freedom with the 0.05, okay, two tail. 25 degrees of freedom with 0.05 two tail. What value do you get? You can tell me. What value do you get? What value? Because that value is our critical value. What is the value? Marcus.
2.060.
That is a right answer, and that is our critical value. So once you know that, you come down to your calculation and write that this is actually equal to, okay, this is actually equal to 2.060. So your critical value is 2.060. That is your tabulated. Your calculated was 1.82. Okay, 1.82. So now you can use this critical value approach, which Isa taught you. You can use the critical value approach to conclude. And here is the conclusion. The conclusion should always be based on something like this. If the calculated value is greater or equal to the tabulated value, reject the null hypothesis. Okay. This is your condition. This is a decision rule. If the calculated value, the t calculated, is greater or equal to the t tabulated value, reject the null hypothesis. Now, in our own, our calculated value was what? 1.82. Our tabulated, 2.06. Forget about whether it was negative or not, because we are dealing with absolute values. Okay, we are dealing with absolute values. So, is our calculated greater than the tabulated? Is our calculated greater than the tabulated? So, what do you think will be our conclusion? Who can tell us? Is our calculated greater than the tabulated? What do you think will be our conclusion? Is our calculated, is it greater than the tabulated? And if not, what will be our conclusion? What do you think? The conclusion. The conclusion is going to be, yes, Shadrach.
So our T calculated was actually lesser than the tabulated. And per the condition above, we would have to accept the hypothesis.
Okay. So let's just say we fail to reject. Okay. We don't usually want to say we accept, because otherwise we'll fall into a certain type of error. Okay. But we fail to. We don't want to commit type 1 error. We fail to reject the null hypothesis. So we cannot reject the null hypothesis. Okay. We cannot reject the null hypothesis. That's what we say. That since the calculated is less than the tabulated, we cannot reject the null hypothesis. So what's going to be our conclusion? What was the null hypothesis? Well, don't forget that this was our null hypothesis. The null hypothesis said that this was a null hypothesis. It says that the turnover, the weekly turnover is actually 5,000. We can't reject that. And we also implied at the time that what the null hypothesis means is that we have to buy the SME. Now, we can't reject this null hypothesis. So what is going to be our conclusion? Practical conclusion. What will be our practical conclusion? Who can guess? Emma.
It means that we should go ahead and buy the SME.
Perfect. It means that we should go ahead and buy the SME. Now, all of these are in the slides, and I want to show you something a bit as they are in the slides. Okay. As they are in the slide. So when you look at this conclusion, it's the same thing, what she said. But even what it was done here was beautiful. It says that since the calculated is greater than the tabulated, and you see the way it's been written nicely, calculated is greater than tabulated, we don't reject the null hypothesis at the 5% level of significance. At the 5% alpha, always you want to add that at the 5% alpha level. And we conclude that the weekly turnover is indeed 5,000. What the current owner was telling us is truly 5,000. And so nothing prevents us from buying the SME. So we can go ahead and buy the SME. That is a conclusion using the critical value approach. Now, let's try to answer the same thing using the p-value approach. Okay. Remember the p-value approach. The p-value approach is a simple approach that says that use the p-value to decide whether alpha. So we are going to compare the p-value and then the alpha level. That's what we are going to do. How do you do that? Well, here is a clue. The clue is that always use the calculated to find the p-value. This point is important. Okay. Always use the t statistic, which is also called a calculator. Use a t statistic to find the p-value. Once you understand this, there's no problem. Okay. Now, what is our t statistic that we got in this? What was the value of our t statistic? Okay. The value of our t statistic in this very question, what was that? It was equal to 1.82. That was our t statistic. So we are going to now take this t statistic, which is 1.82, go to the table and then drop it, boom, into the swimming pool of the table. We are going to drop it into the table. So this is a table. We are now going here, and remember the value is 1.82. We are going to look for 1.82, not on the edges like we did before, but this time inside the swimming pool. We're going to look for a number closest to 1.82. A number closest to 1.82. Search. This is where you search. And of course, the numbers have been nicely organized in such a way that you should be able to identify it. Okay, 1.82. Obviously, we won't come to the far left here. You'll be going to the right there. 1.82, 1.82, 1.82, 1.82. Search, search, search. And you can see that the closest number here is 1.833 and then 1.81. Those are the closest numbers. That 1.82 is in between these two numbers. Okay, and therefore our two numbers are this. And always the clue is that even if there are two numbers, there will always be one on top of the other. Remember, your focus is not to actually find 1.82, but it's to use that 1.82 or the number closest to that 1.82 to get the p-value upward. So once you identify that this is the number or the closest number, read it, climb up until you get to the black numbers, which is the p-value. Now there are two of them, and don't forget one of them is a two-tail and one of them is a one-tail. One of them is the p-value. So on the basis of this, what is the value of the p-value? Who can tell me what is the p-value? Based on this search, what would be the p-value? What do you think is the p-value? Okay. What is the p-value? Tariq?
0.0.
0.05. That is wrong. Tariq, that is wrong, because if you look at what I did, I said you should look up, okay, the number is there, and I say read up until you get to the top. And when you get to the top, one is one tail, look on the far left, and the other is two tail. And you know that we are dealing with which tail in this very question? We are dealing with two tails.
Oh, sorry, Doc, it's 0.1. 0.1, sorry.
Of course, if it is not one, it's the other, but you need to understand what will happen here. Okay. So the true value is 0.10 because that is a two tail. So now that you know this, you come and then document that. Okay. Okay, you document that down and indicate clearly that the p-value is equal to 0.10. Now remember the p-value is 0.10. What was our alpha? Alpha was 0.05. And here is a rule. The rule is that if the p-value is less than or equal to the alpha, then reject the null hypothesis. That's when you reject the null hypothesis. Okay. If the p-value is less than or equal to the alpha, reject the null hypothesis. So guys, let me ask you, should we reject the null hypothesis or we don't reject the null hypothesis? Should we reject the null hypothesis or we don't? Shelley?
We don't reject it.
Exactly. So what should be our conclusion if we are not rejecting it? Shelley, what should be our conclusion if we are not rejecting it?
We can actually go ahead and buy the SME.
Exactly. So what this means is that the conclusion will be the same. Now, different approach but the same conclusion. Anytime the p-value approach says reject the null hypothesis, the critical value approach should also say reject the null hypothesis. And they should all lead to the same conclusion, which in this case is go ahead, buy the SME. Nothing prevents you from buying the SME. Okay. So now let me take you back to the entire storyline here. When you go to the entire storyline, you will see from here that that's the same conclusion. This is the p-value conclusion. That since the p-value of 10% is greater than the alpha value of 0.5, we do not reject the null hypothesis at a 5% level of significance. And we therefore conclude that nothing prevents us from buying the SME. You have been able to use statistical torturing, statistical knowledge to arrive at a concrete conclusion. And this is what hypothesis testing, hand computed, is about. Okay. The computer can do this thing, but even if the computer works it for you, the computer will expect you to use the p-value and compare it to the alpha eventually to come out with the right answer. We shall use our software to be able to find some of these computer tricks. But this is where you master this. I have an example for you to look at here, okay, about a certain storyline similar to this, but this one you have to calculate the mean, the sample mean yourself. The population mean, you will notice it somewhere, and the sample mean, you calculate it yourself, and then, you know, the standard deviation has been given to you here. You should be able to use that to conclude whether the data supports the claim of Duffiasam. Duffiasam is a tomato grower. He has developed a new variety of tomato, and he claims that the average yield per plant is at least 4 kilograms of fruit. A certain gardening magazine wanted to test the claim. So he decided to measure the yield and obtain that standard deviation. The yield that he got over time was 3.6, 4.2, all the way up to 4.2, 4.5. Your job is this: formulate a hypothesis, use the P and critical value approach, and then check whether the data supports the claim of Duffiasam. Do this, and you will by all means stand on your own acre of diamonds.